Hello all, today we are back with Chapter 1, Measurement, and today we have a dimensional analysis problem that will really challenge your conceptual theory about and your conceptual knowledge about dimensional analysis. This is a little challenging, but I think you all can do it and try to follow along, and if you can, pause the video and try and solve it by yourself. Okay, we're gonna start now. Given the following measurements and about the graph below, calculate the length of 50 alphas in betas and omegas. I'm just using these Greek letters for placeholders right now. So basically what we're trying to calculate is 50 alphas in the form of some number betas and some number omegas. So how we're going to go about this is, of course, using dimensional analysis. Looking at the graphs over here, we can see that these two, alpha and beta, both start at 0 and both end at the same mark, although they have different values at the same mark. Looking at the comparison between alpha and omega, we see they have a similar mark over here when alpha is 22 and omega 75, and a similar mark over here where alpha is 100 and omega is 300. So, moving on to the problem. So, since we know that alpha and beta both start and end at the same point, although they have different values, we can come up with an equation that will help us find the relationship between alpha and beta. So looking over here, we see that the length of 100 alphas equals the length of 200 betas. So that will be our first equation. 100 alpha equals 200 beta. Moving on, we see that 22 to 100 alphas equals 75 to 300 omegas. This might be a little challenging to go at first, but we can use a simple subtraction to find us the answer. So 100 minus 22 alpha, because we're only looking at the distance between these 2 points. So we know that the distances are equal. So we wouldn't say that 300 equals 100 or 200 equals 75 omega. 22 alpha equals 75 omega. We would have to subtract to find the distance between them. So on the other side, we would have 300 minus 75 omega. Okay. Oh, my parentheses are a little off here. So taking our first equation, we can simplify this to alpha equals 2 beta. Taking our second equation, we can simplify this to 100 minus 22 is 78 alpha, which equals 300 minus 75, which is 225 omega. So here we have some kind of conversion tool that we can use later to find the length of 50 alphas. So this is the part where we need to use actual dimensional analysis. So 50 alphas can equal 50 alphas times 1. We all know that's true, right? But we can also rewrite 1 as 1 alpha over 2 beta. This is true because of this equation over here, where 1 alpha equals 2 beta. And you know when two quantities equal each other, when you divide them by each other, you will obviously get 1. So we are making use of this property over here. So we know that 1 alpha over 2 beta equals 1. So looking at this equation, we want to make sure that the alphas cancel out. This will not happen if we multiply it by 1 alpha over 2 beta. So we will multiply it by the reciprocal of the fraction, which is 2 beta over 1 alpha. This also equals 1 because of the same property I mentioned before. So now our equation is 50 alpha times 2 beta over 1 alpha. In this case, you can cancel the units out. Remember that the main part of dimensional analysis is to make sure that you translate the units into a new unit. And we are doing this here when the alphas cancel out. So now we have 50 times 2 beta, which equals 100 beta. So now we know that 100 beta equals 50 alpha. Moving on to the second part of our equation where we are solving for omega, we see that we have the conversion factor over here, that's 78 alpha equals 225 omega. So using the same idea that we did before, and by using the fraction that equals to 1, keeping in mind that we do want the alphas to cancel out once more, we have the equation 50 alpha times 225 omega over 78 alpha. So now we can cross out the alphas. So now we have 50 times 225 divided by 78 omega. So let's plug this into our calculator. 50 times 225 divided by 78. And we get 144.23, approximately that, omega. So that will equal to 50 alpha. So in this problem, we explored how dimensional analysis can help us convert these lengths into different units, from alphas to betas and alphas to omegas. And I hope this video really helped you with your deepening your understanding of dimensional analysis. Thank you for watching.